No, that's us. Hi, everybody. My name is Davor. We are at InfoBip Shift. Today is 16th. Nothing unusual. So today's agenda, hopefully, if this thing works. If not, never mind. I'll talk a little bit about multi-agent system powered by large language models. And I will talk about two libraries, frameworks, which actually makes those things easily available to everybody. It's been in development for about a year now. And it really reached, I would say, maturity level that we are starting to see them more and more in production setting. I actually applied for this talk like a week ago, which is obviously too late, because the library just was released like on Friday. And the reason why I wanted to do it was because the last year I was here, maybe like a room next to it, introducing the FastStream, another open source library that we just developed. And it's kind of a lucky charm to present it at InfoBip Shift. So we created one open source library, which we also use for these multi-agent things. But at the time, we just said this is like very good for if you have some kind of streaming protocols, whatever they are. And we got some questions about why do we think that such library is needed. And a year later, it's quite clear why. Because we got the API right. So the two main competitors at the time, much more ahead of us, were Bytevex and Faust. And the question was really, do we really need another library? And the answer is always yes, if you can find a better developer experience. If you can reduce the amount of code that people need to write, if you can reduce the complexity, then things will just take off. The good thing about it, it was also chosen to be one of the top open source projects last year. So we have high hope for this one. But today I'm going to talk about AutoGen, which was also one of the top projects last year in this same competition, and also Fastagency, which is our runner for this year. So you probably all know large language models, GPTs, unless you're living under the rock. And there are a lot of good things about it. So especially if you want to use them not just for chatting, but actually building an application from it. They're extremely powerful. We have never seen anything like that, like something that can really understand the user intent, process text. We have never seen anything like that before. It really works. You can build fantastic user experience. We have witnessed all of that things. It's very easy to build complex solutions. They do all the hard work. But they have some bad sides of it. One of them is lack of control. If you ever try to do something with them, for some reason, they do not listen to you. It's not like typical programming. You change line of code, you do something, and then execution. No, you change line of code, God knows what happens. And then you iterate, and everything works, and then after a month, it stops working again, God knows why. Huge problem is hallucination. You give it a problem, task, for some language model to do, it starts doing other stuff, God knows why. It's a huge problem. And can be expensive at scale, because if you really want to reduce the lack of control and hallucination, you're going to need to use the top language models, and that costs money. That's not cheap. And that was about the stage of the art until the last summer, when something like this came up in the news. AI chatbots tasked for producing a software. Software, up to 1,000 lines of code. But they were able to finish it, all of them, in the benchmark, 17-something different kind of programs. Under 7 minutes, average cost $1. And that was a huge thing, because no one understood how it works. Because whoever tried anything like that, he knew for certain it's not possible, because you don't have a control, it's hallucinating, you cannot get 100% or anywhere like close to 60% of actually success rate on those kind of things. But suddenly, they were able to write code. And the reason why they did it, the trick behind it was not just large language model solving the problem. It was a team of large language models solving the problem, assuming different roles. One as a CEO, chief product officer, CTO, and then product owner, and then there was a developer, there was a tester, there was a quality assurance, there was design. There were like a bunch of roles. And once they started interacting, all those problems went away. And this is example one of those conversations. So Somebody wants to build a new application. How should we do it? Well, it should be desktop. Let's decide, should we do it in Python or whatever. And they talk. And once one of the language models start hallucinating, the other ones pull them back in, saying, like, that's not what we are supposed to do. Let's stick to the problem that we have. And that was a huge discovery. The second thing is that you can use much smaller and cheaper language models if you have agents talking about the problem, not just solving it. So what happens is that on a particular benchmark, GPT-3 was doing 48% completion rate. GPT-4, 67, much, much better. But if you put GPT-3 to talk to itself in the multi-agent setting, suddenly you get 95. And that was like mind-blowing. So all of this happened roughly in the summer, end of the year, and one of the frameworks, open source framework that actually popped up, came from Microsoft Research. It's called AutoGen. And it's actually API how to quickly build those kind of things, how to define those agents, how to set them up, how to work, talk to each other, how to give them tools and functions to execute. And we start playing with it. And one of the first things that we did, as an example, was building a fully automated digital agency. Just as it's like a proof of concept. It actually works, but that was not the point. So what happens is that we build a team of different agents, from account manager, digital strategists, Google experts, God knows what, and gave it a task. And the task was this. If I give you some URL, go to that website, read the page, click on links, read more pages, click on more links, figure out what the web is about. And then, once you figure out what the web is about, tell me which pages should be advertised, because I want to boost sales. And then, when you're finished, try to figure out which are the ads, which are the keywords, which are the description, everything. And then, when you're finished, tell me, just ask me, like, should I put this campaign on Google or not? And if I say yes, put it on Google. So there are a lot of things here that has to happen. First, we need to have agents collaborating. We need to have one agent that can actually serve the web and search it. We need to have one agent that can actually access Google API and set up the AdWords. We have to do a lot of things. And we did that, and it looks like this. So these are like internal messages between those things. And this thing actually works. If you put it on a benchmark for a random page, it's around 95% successful. It's about a few days or maybe a few hours of work, done in 15 minutes, for the cost of $1 or $2, God knows what. Like unmeasurable compared to the human thing. And to build this thing, we had to do a lot of work on the AutoGen itself, because it just came out of the research and it was like not ready for these kind of things. So I started doing pull requests one after another, and 55 later, I'm one of the core contributors over there, doing a lot of things about function callings, APIs, streaming, outputting, and God knows what. So what those agents do? Search, serve the web, that's typically what you need to do in almost every task. You have to call some APIs. If you're within the enterprise, it's very security related. Sometimes you have to generate and execute code in Python, sometimes. And you have to collaborate. Make a plan how to do something, discuss it, correct, plan again, try to do something, figure out something is wrong, do it again. And what is the easy and what is the difficult thing? Actually, writing the agent workflow was easy. Because you just say, like, you're the team, figure it out. What was difficult? Testing, bugging, deploying. If I go to that example of putting up a Google campaign, I would say maybe we spent like a week of actually defining the workflow, and maybe 3 months actually building the application. That was a difficult thing. So, for some reason, we like to do hard stuff. So let's solve the hard thing. Let's keep AutoGen doing what it needs to do writing AutoGen workflows, but let's solve the testing, debugging, deploying problem for doing these kind of workflows. And this is why we built this thing with these beautiful colors. Don't ask me. We claim the fastest way to bring multi-agent workflow for production because we did it first, and it's extremely painful. You need some faster way. You really don't have a time to do this. So I'll show you a little bit of first features, and then the example to actually have you second film. So first, one of the things that we noticed that we need to have the same code, but we need to debug it, which usually means some kind of console application. And we also need a way to scale it to web application with message broker, streaming, observability, God knows what. But when you're doing the debugging, you don't really want to see all that heavy stuff. You just want to have like a simple application. So we built a unified API that we can actually just quickly switch from one or another with one line of code. That's what we like to do. A second thing is actually integrating external API. It's a very tiring process. You don't want to give language model access to tokens, keys, or any kind of secrets. So you need to do some wrapping functions, you need to do some code injections. It's not a difficult thing to do, but like if you have API of 10 functions, it's difficult. It takes weeks. So what we built is actually a system that with 2 lines of code, you can just give it REST API specification, an open API specification. It's going to read it, parse it, build a client for it, do the code injection stuff, and just provide you an object that you just say, register to a client, to an agent. And it will know how to use it. It will know how to use it because we parse all the documentation and give it to it in a proper form and everything. 2 lines of code. You need to orchestrate those kind of things. Again, start the application, how to run it, how to stop it. Again, CLI command, 1 line of code. And the tester class, which is not finished yet because it's a version 0.1, and it will be hopefully soon. So how it works. How do I install it? Typical thing, pip install. Because there are so many modules that can be actually in conflict between each other, everything is optional. So you have to say, I want to use AutoGen as a runtime. I want to use OpenAI for the APIs. Please install whatever needs to be installed. And then you import some bunch of things. From AutoGen, you import some stuff. And from my agency, you import UI, Fastagency application, workflows, some OpenAI, God knows what. I'll show you later. So let's say that we want to build a team that can access some kind of weather API. How we will do that? Just like the simplest example possible. So typically, if you have some kind of REST API, you're going to have this kind of documentation, right? It's automatically built by pretty much every tool that there is. And there is something called download over there. So if you have the link, the download, you can actually get the specification in like textual form. This is how you would import that thing in a Fastagency. Here's the specification. It's open API. Please create it. That's it. I don't need to know anything more about it. How would I use it? Actually, if you know anything about AutoGen, this is how typically you would write users, what do they do? I'm weather agent, I'm user, I'm God knows what. How would you attach this API? Single line of code, written in 4 lines for readability, but you just say, this is an object, take care of it. I'm going to call it, I'm going to execute it, please do your magic. Chat result, that's how I actually start the whole thing and return it. And this is the older specification. It doesn't specify what UI, user interface will use. It's just passing it to the workflow. And there are some other functions that sometimes use this thing. How do you create an application? You either say UI is a console or UI is a Mesop UI, which is building the Mesop application for the web server and everything. And then you're going to run it with Fastagency run and the name of the file, whatever. So if I start with the console, it's going to, for example, Fastagency run main. It's going to build the whole dependency tree, whatever you have here. It's going to find it, and then it's going to start the workflow saying, I'm starting a simple weather with a description, weather chat, please enter initial message. And then it's a chat in console, nothing exciting to see. But if you use the other line, Mesop UI, and you start it with this, the message will be different. The message will be, oh, I'm starting a Mesop UI. And here is the link. And if you click on it, you have a chat, which is running in your browser. So single line change, you change all the routing internal and how to use it, because the whole thing abstracts from how the AutoGen is handling messages to what UI should implement. And it's actually very easy to build different kind of applications and UIs and God knows what. The future work tester class, because actually running a CI/CD with the large language models, it's a nightmare. So that's something in the work, but that's actually extremely big problem because you cannot like normal CI run unit tests every single time somebody commits something. That would cost a lot. You need to run it on a regular basis, and you actually have to do benchmarks, like how much I'm better than I was yesterday, because there's a lot of things going in the repository. You cannot run it all the time. And you have to run it for different kind of language models. We're adding support for different user interfaces. So we have 2 already in the works, Fast API, Streamlit, and whatever needs to be done. And we also have fully distributed with the streaming brokers, which is not merged yet in the first version, but actually enables you to scale it to the internet scale, basically. And support for multiple runtimes. So we are coming from AutoGen, but there are other frameworks as well. And we'll support them because the whole layer, which is called runtime, is actually being abstracted. So you have to create this AutoGen object and pass it into the workflow. That was all. Thank you, and I'm